Hello everyone. Today we are going to discuss paper 5 of February March 2023, and in the last class we have discussed question number 1 and question number 2. We have discussed it in detail. Then we have discussed question number 3, then question number 4, and then today we are going to discuss question number 5 onwards. So if you have missed the previous lesson, you can see the link in the description. Now today we are going to discuss from question number 5 to till the last question of this paper. So let's start our class. Question number 5. On question number 5, Marco has 4 boxes labeled K, L, M and N. He places them in a straight line in order K, L, M, N and K on the left side. With K on the left side, this is an important point. Marco also has 4 colored marbles. One is red, one is green, one is white and one is yellow. He places a single marble in each box, okay, at random. Event A and B are defined as the white marble is in either L or box M. This is event A. The red marble is to the left of the box with green marble, yellow and green marble and the yellow marble. Okay. Determine whether or not the events A and B are independent or not. Now the very first thing is, for an independent event, we know that for the independent event, that probability of A intersection B must be equals to probability of A multiplied by probability of B. So this is the rule for the independent events. Now let's find out. Now we know that we are interested in the probability. So which means that first of all we must know that the total number of arrangement for red, green, white and yellow. So let's find out the total number of arrangements for red, green, white and yellow. Now let's see what will be the total number of arrangements. So total arrangement will be equals to 4 factorial, because here we do not have any repeated number and we do not have any conditions. So total arrangement will be 4 factorial, which will be equals to 24. Now we have 4 boxes, and in 4 boxes we have K, L, M and N. Now let's find out the possibilities for A. So first of all, let's do some working for probability of the event A. So for event A, we can see that the condition is that white marble is in either box L or box M. So white marble is in either box L or either box M. So let's see the possibility. So we can see that we will have let's find out the possibilities. This is box K, box L. Now note down one thing, that K must be on the left side, so we have to write it over here only, okay? And box M, we have 4 boxes. Let's see the second possibilities. For second possibilities, we again have 4 boxes. Okay, let's see that the possibilities. Now here for the first one is, we are finding out for probability of A. So event A, the white marble is in either L or box M. So it means that the white marble can be over here and can be over here, box K, L and M. Okay, so it represents K box, L, M, and N. So this is the sequence, so we are following it. So for probability of A, we can see that let's find out the arrangement that it can be either in box L or box M. So now the next step is that we can write it as, how we can write it as? So we can find out the total number of arrangement for the first case. So it will be 3 factorial because we cannot change the box L, but we can interchange, we can find out the arrangement of this one. This can be 3 factorial only, 3 factorial. And what about the other one? So here in the second case, we again will have 3 factorial. So let's see what about 3 factorial. 3 factorial will be equals to 6, which means that this will be 6 and this will be 6. And if we add these two, so this will be 12. So finally, we can say that probability of A, event A will be equals to what? This will be equals to 12 divided by total number of arrangement, that is 24. So which means that this will be equals to 1 by 2. Now this one is the answer for the probability of A. Let's see probability of B. Now for probability of B, we can see that the red marble is on the left of both the green and the yellow marble. So let's see the condition, let's see the cases over here. Now let's do some working for probability of event B. Now for event B, what we can do is first let's find out the cases that we know that let's build the boxes over here. That let's see that we can have 4 boxes. 1, 2, 3, 4. This will be the first case as we have done in the previous one. 1, 2, 3, 4. Now we can see that the first box represents, what was the condition? Let's see the condition first. Now we can see that the red marble is on the left of both the green marble and the yellow marble. So let's move over there. So as per the condition that the red marble is on the left side of both green and yellow, it means that the first possibility is that red marble can be over here, and here there must be white marble, because we have seen this thing that they said that that green and yellow marble must be over here in these two boxes. So let's see the other condition. It is possible that red marble can be over here and white marble can be at any of these places. Okay, so we can see that here these two are fixed. In the first case, white and red are fixed. So remaining places are 2. So this must be, the arrangement must be equals to 2 factorial. And for the second case, this must be equals to 3 factorial. Now let's see that 3 factorial is equals to 6 and 2 factorial is equals to 2. So if we add these two, so this will be equals to 8. Now from here we can see that the probability of B, let's see that probability of event B will be equals to 8 by total, that is 24. So it means that this will be equals to 1 by 3. Now the next step is we have to find probability of A union P. Sorry, not union, it must be A intersection B. Now the next working is for A intersection B, because we have to prove the independence, that whether it is independent or not. Now for this case, what we can do is, we first of all we have to find out Let me write it over here. Find out the common overlap of A and B. So we have to find out the common overlap. So what we can do here, that we can write it as, the first one is that, let's see the first condition, that it must be R. Now it satisfies both the conditions. That the first case is that white marble is either in box L or box M. And the second one is that the red marble is to the left of the green marble and yellow marble. So it means that red marble can be over at this place, and red marble can be at this place again, and the white marble must be over here because it can be in the K and L. So it can be in L and M. So we can see that we will have these two possibilities. This is the common point for both the regions. So what we can do is, so these are the total possibilities. Total possibilities. So these are the total possibilities. So let's find out A intersection B. So for the first case it will be 2 factorial, because we can see that it has two places, and for the second one again we can see that it has two spaces, so 2 factorial, so the final answer will be 4. Now probability of A intersection B will be equals to 4 divided by the total arrangement, so it will be equals to 4 by 24. Now, and if we further simplify it, so this will be equals to 1 by 6. Now let's see the condition of possibilities. So the condition for possibilities will be probability of A intersection B is equals to probability of A multiplied by probability of B. So let's check this one. So as you can see, A and B is 1 by 6. And what was the probability of A? Probability of A was 1 by 2 and probability of B is 1 by 3. So as this condition satisfies that 1 by 6 is equal to 1 by 6, so we can say that these two events are independent, and hence prove. Now let's move to the question number 6. Let's move to the next question. Now let's see the next question. Question number 6. In a cycling event, the times taken to complete a course are modeled by a normal distribution. Now this is the first hint that we have got, that it is a normal distribution with mean is 62.3 minutes and standard deviation is 8.4 minutes. Find the probability. Now we have to find out the probability that a randomly chosen cyclist has a time less than 74 minutes. Now this is a very simple question. Now we know that what is the mean and what is the standard deviation, we can directly use it. So here what we have to do, we have to find out the probability of less than 74, the random variable less than 74. So this will be equals to, we can write it as, we can replace it with z, and the formula for z is mean x minus mean divided by the standard deviation. So here the value of x is 74 minus mean, that is 62.3 whole is divided by 8.4. So let's find it out. So probability of z less than, now let's use the calculator. So 74 minus 62 0.3 whole is divided by 8.4. Now this will be equals to 1.3939 and so on. So we can say that this will be equals to 1.393. This is the value of z. Now let's find out, let's see the table first, and from here we can see what we have to do. We have, this is a normal distribution table, and we have to find out, let's say this is the value of z is equals to 1.93, and from here we can see that we have to find out this value. This is the value, so we can directly use the table, using table. So from here we can use the table and see the value at 1.93. so probability of z less than 1.93 393. So let's see the table, let's use the table over here. 1.393. so where is 1? This is 1, 1.393. so 3, this is 3, 0. So 1.3 we have to follow 1.3. so this is 1.393. so this is 9 and this one is 3. So 0.9177 plus 5. Let me write it over here. 0.9177 plus 0.005. So this will be equals to 0. Okay, there must be one, there must be another 0 over here. So this will be equals to 0.9182. Yes, 0.9182 will be the final answer. 0.9182. So this will be the final answer. This will be the final answer. That's it. Let's move to the second part. In the second part, they said that find the probability that for randomly chosen cyclists all have times between 50 and 74 minutes. So what does this statement mean? This statement means that probability of 54 less than x, this will be 50. Yes, 50 is less than x less than 74. So we have to find out this thing. So let's convert it into z first. So z means that we know the formula for z is x minus mu divided by the standard deviation. So 50 minus, now mu was 62.3 whole is divided by standard deviation, that was 8.4. Now the second one is 74 minus 62.3 whole is divided by 8.4. Now from here we can write it as, let's simplify this one, that this will be 50 minus 62.3 whole is divided by 8.4, 8.4. So this will be equals to minus 1.464. So we can write it as probability of minus 1.464 less than z less than what? This was, I think we have find it out. Previously we have done it. So let's do it again. That this will be equals to, if it is 74, then this will be equals to 1.393. So let's write it over here, 1.393. Now from here what we can do, we can just see the probability distribution diagram, and let's try to understand it. Let's try to understand the concept. And here the concept is that we have to find out these two values. So let's say this is the mu over here, and this one is 1.393, and this point is minus 1.464. We have to find out the region between these two. We have to find out the probability between these two. So from here what we can do, we can write it this one as probability of 1.93, z less than 1.93, because we know 393, sorry, this must be 1.393 minus probability of z less than minus 1.464. So what does it mean? It means that why we are writing it like this, because we know that the table will share the value of z less than this thing. So if we find out for 1.93, if we are using the table, it will give us the value from this point to this point, and 1.64. So it will tell us the value from this point to 1.64. So if we subtract 1.64 value, 464 value from the other value, it will give us the region between these two. So that is why we are writing it like this. So now what we can do, we can use the table. So for z is 1.393, we have find it out in the previous part, that was 0. Let's see this one, 0. We can see that we have already done this thing. So 0.9182. So 0.9182 minus, now we can write this one as 1 minus probability of z less than 1.464, because there is a case of symmetry. In normal distribution, there is always a chance of symmetry. Why? Because we know that for negative values, let's say this is the required answer. So as we can see that this is a symmetry. So symmetry means this region and this region will remain same. So they are identical. We can say that they are identical. So how to find this region? So we can find out this region. By subtracting it from 1 minus z less than 1.464. So now we can write it as 0.9182 minus 1 minus, now what will be the answer for this one? 1.464. Just use the table. So this will be 1.46 and 4. This one is not the 4. 4, 6, and this will be the 4. Yes. So we can write it as 0.9279 minus, plus 0.0006. So this will be equals to 0.9285. So we can write it as 0.9285, and if we subtract it from 1, what will be the answer? 1 minus answer. So it will be 0.0715. 0.9182 minus 0.0715. So if we further simplify it, so we can write it as 0.9182 minus answer. So it will give us the final answer, that will be 0.8464. So probability of probability of between 54 less than x less than 74, this will be equals to 0.8467. So this will be the final answer. Now let's see that this is another important point over here, that we have to find out 4 randomly chosen cyclists, not a single one. So it means that we have to multiply it with 4. So we can write it as probability of 4 cyclists between 50 to 74. So this will be equals to 0.8467 multiplied by 4. So multiply by 4. So this will be equals to 3.3.0. Let me write it again. 0.8467 multiply by 4. So this will be equals to 3.3868. We need to revisit this one. So because probability cannot be greater than 1, so the final answer in the marking scheme is 0.5139. So this will be the final answer. I hope that the concept is clear. Let's move to the next part. Now let's see part C, that in a different cycle event, the times can also be modeled by a normal distribution. Now it means that this is a normal distribution, whereas the times, now it means that the random variable, this is the time is x. 23% of the cyclists have time less than 36 minutes, and 10% of the cyclists have greater than 54 minutes. Find estimate for the mean and standard deviation of the distribution. Okay, now here we can see that probability is given to us. Now we can see that this is x, time is the random variable here, so which means that probability of x less than 36 is 0.1. Less than x is 0.23. Now this will be 0.23, and probability that is greater than 54, it means x is greater than 54, is 0.10. Now as we can see that it is a normal distribution, so we know that we can convert it as z is equals to x minus mu divided by sigma. So from here we can write it as probability of z is less than 36 minus, what was the value of mu? We don't know. So mu divided by sigma is equals to 0.23, and here this will be probability of z greater than 54 minus mu divided by sigma is equals to 0.10. Now here we can see that in the table the probability starts from 0.5, and which means that here we will have like this way. This is the normal distribution curve or the graph. So for z, when z is positive, this portion is equals to this portion. So here we can see that this is equally distributed, and these two are the symmetrical area. So we can say that z positive and z negative, we can convert it like z positive and z negative. Now here we can see that the value of z is 0.23. So let's subtract it from from 1. 1 minus 0.23 is equals to 0.77. Now from here we can see, we can use the table. So by using table 0.77, what we can do, 0.77. So where it is 0.77. So here we can see that this one is 0.77, 0.73, okay, 0.73, and we need 27 over here, so this must be this one. So it means that we can see the values over here, that this will be 0.739, so it will be 0.77. So by using table we can see that z will be equals, the value z will be equals to 0.739. Now we can equate it like we know that x is equals to z is equals to x minus mu whole is divided by sigma. So 0.739 is equals to, in this case x was 36 minus mu whole is divided by sigma, and if we rearrange it, so this will be the, let's say this will be the first equation. Now the second one, let's see the other one. Now here we can see that this is 0.1, so we can subtract it from 1 minus 0.1 is equals to 0.9. Now using table, now let's see the table. Here again 0.7, so we can see that that is 0.9. Where is 0.9? We can see here that this will be 1.28. Yes, this one 0.8997 plus 3, we need 0.8997, 1.8, 1.281. This will be 1.28 and 1. Yes, this is closest to this one, so we can say that from here we can see that 1.281. So z will be equals to 1.281. So 1.281 is equals to 54 minus mu whole is divided by sigma. So this will be the equation 2. Now if we simultaneously solve equation 1 and equation 2, we will get the values. So from here we can say, let's say from equation, we can write the equation 2 as 1.281 sigma is equals to 54 minus mu. So from here we can write it as sigma will be equals to 36 minus mu whole is divided by 0.739. So simply put equation 3 in equation 4. So it will give us what? So it will give us 1.281, 36 minus mu whole is divided by 0.739 is equals to 54 minus mu. So from here we can write it as, if we further simplify it as, so this will be 1.281 divided by 0.739. So it will give us 1.733. So 54 divided by 54. Okay, let's see again. 1.7339 multiplied by 36, so it will be 62.4. So 62.4 minus 1.7334 is equals to 54 minus mu. So this is mu over here, so we can shift it to the other side. If we simply rearrange it, it will be 62.4 minus 54 is equals to 1.7334 mu minus mu. So this will be equals to minus 54. This will be equals to 8.4. So 8.4 is equals to, if we subtract it, so 0.7334 mu. So divided by 0.7334. So this will be equal to 11.45. 11.46. So mu will be equals to 11.46. So this will be the answer for mu. Now we can put it to the other side. Just put it over here. So sigma will be equals to, so simply put it over here. So 36 minus answer, that was the previous answer, divided by 0.739. So this will be equal to 33.2. So 33.2 will be the value of sigma. So this will be the final answer. I hope that the concept is clear. Let's move to the next question. The last one, question number 7. Question number 7. Find the number of different arrangements of the letter 9 letters in the word delivered in which the 3 E's are together and the 2 D's are not next to each other. This is an important point. So let's assume that here the condition is that we have 9 letters, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 letters, so we can write it over here. So E, and this one is E. So further we can simplify it. This is the first portion. This is the first portion. And the remaining 6 letters will be D, L, I, V, R, D. So these are the remaining 6 letters. Now from here we can see the total number of ways. So let's find out the total number of ways. That will be, now here we can see, let's consider it one variable. Like here, this will be the 1. So 1, 2, 3, 4, 5, 6, and 7. So total we have 7 letters. So 7 factorial divided by, let's see the repeated numbers over here. So here the repeated letters will be D. So we can write it as 2 factorial multiply by. Now for this box, we can write it as, we have 3 spaces. So 3 factorial. So now repeated letters are 3. So that will be divided by 3 factorial. So the final answer will be 7 factorial divided by 2 factorial. So we can write it as 7 factorial divided by 2 factorial. So this will be equals to 2520. Now let's see the other way, that D's together. Now they are saying that these are not together. So first we will find out, let's find out the D's are together. Then we can subtract it from the total one. So together, let's D are together. For D's are together, so how we can simplify it? So this will be, the case will be, we have 3 E's, and then we will have 3 D's, and then we have the remaining 4 letters, 1, 2, 3, and 4. Now this is one box. This is one box. This one is the second box. So let's see. Now we can see that 1, 2, 3, 4, 5, 6. Now we have 6 spaces. So we can write it as, when D's are together, let's find out the arrangement. when these are together. When these are together, so we will have 6 factorial divided by the repeated letters. Now here we can see for these 4 places, we will have L, I, V, R. So we will have 4 letters. Nothing is repeated. So we can write it as 6 factorial, and then further we can write it as, now for this box we can write 2 factorial divided by 2 factorial, and for this box we can write 3 factorial divided by 3 factorial. So finally the answer will be 6 factorial. So here this will be 6 factorial. So 6 factorial is equals to 720. Now when E's are together and D's are not together, let's find out the total number of arrangements when E's are together and D's are not together. When E's are together and D's are not together, in that case we have to subtract it. 2520 minus 720. So we can write it as 2520 minus 720 is equals to 1800. So this will be the final answer. Let's move on to the next part, part B. Now in this part, find the probability that a randomly chosen arrangement of the 9 letters in the word has exactly 4 letters between the twos. Now here again the keyword is the word arrangement, so it means we have to use factorial or permutation. So let's find out again exactly 4 letters between the two D's. Okay, between the twos. Okay, fine. Now it means that this is an important point, so let's highlight or underline this point, that exactly 4 letters between the two D's. Now let's try to understand the question here, that we have total 9 letters. Let's find out the total possibilities. Let's find out the total possibilities over here. So let's say if the first D is here, so it means that the next D will be 1, 2, 3, 4. So next D must be over here. Now let's see if the D is at the second place, then here the D 1, 2, 3, 4, D must be over here, so that we will have exactly 4 letters between these two. Now if the D is here, so it means 1, 2, 3, 4. So next letter D must be over here. Now if the D letter is here, so 1, 2, 3, 4, next D letter must be over here. Now here we can see for the first case we will have, as we have to find out the arrangement. So for the first case this will be 7 factorial, because we have 7 spaces remaining, and among those 7 spaces we will have 3 repeated letters. So 7 factorial divided by 3, and for each case we will have the same thing. So we can multiply it with 4. So let's see, 7 factorial divided by 3 factorial. So this will be equals to 840 multiplied by 4. So this will be equals to 3360. So finally if we add all of them, so this will be equals to 3360, because for each case we will have the same thing, because 7 factorial divided by 3 factorial, 7 factorial divided by 3 factorial, 7 factorial divided by 3 factorial. So for each case we will have 840 arrangements, and if we add all of them, we will get this one. Now let's find out the total number of arrangements. So let's see that the total arrangements, because we have to find out the probability. So for probability we have to divide it with the total. This must be total. We have 9 letters and repeated, 3 E's are repeated and 2 D's are repeated. So this will be equals to 9 factorial divided by 3 factorial multiplied by 2 factorial. So this will be equal to 30240. 30240. Now we can see here that the probability. So the probability will be equals to this will be equals to 3360 divided by 30240. So this will be equals to 3360 divided by the answer, that will be equals to 3360 divided by the answer, that was, let's see, 3360 divided by 30240. This will be equals to 1 by 9. So 1 by 9 will be the final answer. Let's move to the next one. The last part, that 5 letters are selected. Now from here we can clearly see that the keyword is selected, which means we have to use the combination. From the 9 letters in the word delivered, find the number of different selections if 5 letters includes at least one D and at least one E. At least one D and at least one E. Now let's find out let's make the column first. So we can see, let's see that we have total 9 letters. So letters other than D and E, that will be 9 minus 5. This will be 4. Why 5? Because we have 3 letters, we have 3 D's and 2 E's. Total we have 5, so other letters will be 4. So we can write it as, let's make the table over here. So we have two conditions, D and E. Now at least one D and at least one E. It means 1 1. And let's see the other arrangement, that will be 1 2. We have to select 5 letters. So 1 2 3 4 5. So this will be, here the first letter will be D. We can write it over here, D and E, and we have 3 spaces remaining. So what we can do, we have total 4C3. Let's see, we have 2 E's and 1 D. So 2 E's and 1 D means that now DE, now we will have D, E and 2E. So we have 2 spaces, so 4C2. Next case is, let's say we have 1 D and 3 E's. So it means D, E, E and another E. So here this will be 4C1. Now here the next case is, we have 2 D's and 1 E. So it means D, D and E. So which means 4C2, because we have 2 spaces remaining. Next one is 2 and 2, which means D, D, here again E and E, which means this will be 4C1, because if you will have 1 space remaining. Next one is 2 and here this will be 3. So this will be, we have 2 D's and 3 E's. So which means that this will be 4C0, because for this case we do not have any space. Now let's find out it one by one. So the first case is 4C3. So 4C3. So this will be 4C2. So this will be 6, 4C1. So 4C1. So this will be 4. Again 4C2 is 6, 4C1 is 4 and 4C0. Let's see that what will be this one, 4C0. So this will be 1. So that is, it will be, if we add it, so this will be 25. So finally we can say that we will have 25 ways as per the given condition. So this will be the final answer. So today that is it. So today we have discussed from question number 5 to question number 7, and if you have of the paper February March 2023, and the variant was paper 5-2. And if you have any question, you can ask it in the comment section. Thank you.